My name is Goce. I'm the head of development in Endava, and I will continue with the boring part, the technical part, actually, from this blockchain technology. I want to share with you some exploration that I did when I started involved more deeply into the blockchain. So, our journey. First, would like to start with showing what's the ecosystem like, what are the blockchains doing right now in the world, compare some of the tools and the technologies there, Ethereum and Hyperledger, discuss about something called the next big thing in web and decentralized applications, and I will try to show you what it looks like to build a decentralized application using the Ethereum blockchain. At the end, give my vision about what might the future look like using these technologies. There have been a lot of initiatives to classify the blockchains that are out there. So this is my goal on the classification part. Owen also mentioned that it all started with the Bitcoin back in 2009 when the initial paper introduced the technology. It was interesting there, and the Bitcoin used this technology to transfer value from one to another account. The first cryptocurrency there, everybody wanted to have a piece of this, and it started spreading from there. But the technology, as every technology, when it starts, it has its limitations, it has its issues, and after a while, some of these issues started popping up. So, is it a database? Is it not a database? Is it fast? Is it not? And some of these blockchain improvement processes or requests came in, and there were some mutations of the technology. This is how additional stuff started to pop up. This is how Litecoin, for example, wanted to solve the issue with having a huge database and having not so responsive database, for example. And this is how Zcash wanted to resolve the privacy issues of the blockchain. At the moment, there are close to or around, and maybe even more than 700 coins out there. So they are all operating in a different kind, but currently none of them is cooperating with each other. So this is why I say blockchains are running wild in the world. On the other hand, after Bitcoin was introduced, somebody saw the potential about this technology, and the idea was the smart contract. So even Bitcoin had a smart contract in it, but it was implemented in only one way, to transfer value from one to another account. So this was what it was supposed to do and nothing more. But a colleague of ours, basically, and a cryptocurrency researcher, Vitali, saw the potential of it and started the Ethereum. So he saw the potential about us being able to define different types of code that can be executed when we initiate an event on the network. And this is actually the smart contract. This started a different type of blockchains or blockchain technologies that are out there. So next to Ethereum, I have the Hyperledger. It also has smart contract capability embedded into its core, but it's more enterprise-centric, and we will see a comparison afterwards. I also wanted to mention something interesting, because in online you can read about that this can actually solve some problems in decentralized voting applications, and we all know the elections and stuff that are happening. So, but there is also an interesting thing about this Tezos, that it wants to solve some of the issues that currently Ethereum has. So there was this mention about proof of stake as the next consensus mechanism that will actually solve some problems for the Ethereum, and Tezos wants to use this. And also there is one more thing with the Ethereum. As you initiate a transaction or something, you do a contract, and if something is wrong with the logic in the Ethereum, it's out there in the world. So everybody is actually wrong. And this is where we have these hard forks, because we cannot change the data that was actually changed by mistake, by some contract, or by some bug in the code. Tezos wants to tackle this issue as well, and they call it a self-governing mechanism. They want to implement something inside. Basically, the network should mutate when by itself. So it's going to be an interesting period to see how this goes. Another thing that we have related to the classification of the blockchains is how we see the blockchains or how we use them. We all know about the public blockchains, and these are the blockchains that can actually be used by everybody. They have the proof of work, they have the security and the trustworthiness built into their algorithms, and they can be used by something called a wallet. So it's basically a software that can communicate with other peers and exchange information and share the database. And everybody can use it. On the other hand, we have the technologies that actually enable us to build these private implementations or private blockchains. These are really interesting for the enterprises, for example, banks or for insurance, because they have a lot of sensitive data. And these are really highly regulated, they are closed, they are not open. On the middle, we have the federated technologies or the federated blockchains that actually have something from both worlds. So usually they have an authority that enables part of the applications or the nodes to get into the network, and this is regulated either through certificates or either through some other means. Here we can see some of the specifics that describe the public, private, or permissioned or permissionless blockchains that we might have. And as you can see, Bitcoin and Ethereum are permissionless public networks, and they use the proof of work already mentioned consensus mechanism. So it's really hard consensus mechanism. That's why it's slow, and that's why it spends a lot of energy. And that's why there are improvement processes in place in order to move to something different. So the next big thing into these networks might be implementing the proof of stake consensus mechanism, and this is kind of coming in the next generations of Ethereum. We will discuss about these generations later on. On the lower right hand, we have the permissioned private networks. These are something that we can have if we use tools like Hyperledger. And these, because being highly permissioned and being highly private, so everybody that's communicating on the network is known and this is regulated, they can use a pretty simpler, I would say, mechanism for consensus. And this is the practical Bayesian fault tolerance mechanism that they use. That's why they are faster, and that's why they are used maybe in the finance domain or insurance. The other thing is the permissionless private blockchains that we might use, and this is where we might be expecting the interplanetary database. So it's something coming from Mars, for example. What is out there in order for us to start developing something on a blockchain? So on this table we have some of the technologies out there, but basically there are two ways that we can go. One way is if we target a specific blockchain, and the other way is if we target a specific tools or sets of technologies. This is where maybe Ethereum and Bitcoin comes in the blockchain first approach, and in the development platforms this is where Hyperledger and Tendermint come. So they have a set of tools and they have a set of frameworks that you can actually use. You need to be highly trained into these because they are not that straightforward as the other platforms, and to know how to architect or how to make this sort of application. I would like to mention a highly specialized company that's called ConsensusSys that basically implements solutions and provides IT services into this technology. This is the organization that actually developed the tools for Microsoft that we have now into Visual Studio and we have now in the cloud. So Microsoft can provide this blockchain as a service. Okay, so I would like to take some time and see what are the differences between the Ethereum platform and the Hyperledger tool or set of technologies. First of all, I would like to mention that the Hyperledger is not another blockchain. A Hyperledger is basically an initiative that started 2015 by the Linux Foundation, and the idea behind this initiative is to provide an umbrella where we can have a lot of tools that can help us to utilize the blockchain technology. So it's not just another blockchain. It's pretty complex. So because it's targeted for enterprises, it's pretty complex and there are a lot of tools out there. So, but on the other hand, because it started from the enterprises, so some of the contributors are, for example, IBM and Hitachi or Fujitsu, or some of the largest banks in the world, and it all started with them wanting to utilize the technology but wanting to utilize it in a private way. So this is why the tools that we have there enable us to have private implementations or private usage of this. If I say blockchain, someone might say this is not a blockchain because it's private. So this is why we are allowed to say distributed ledgers. So it uses the practical Bayesian fault tolerance theory or mechanism. It uses Go language, on contrary to the Ethereum that uses Solidity. It has its own virtual machine, but it's not the virtual machine that's used or the same type of virtual machine used in Ethereum, like the Ethereum virtual machine. This is all specific stuff implemented, and we already have these Docker containers that basically contain all of these implementations. So it's not that straightforward like the Ethereum. Ethereum, you have just the software and there you go. So it's massive, it's modular, and it's a set of development and infrastructure tools. So these are the basic difference that I would like to share here. In the Hyperledger, there is some different paths that you might take or different tools that you might use. So you have the Hyperledger Fabric that actually allows you to start working and developing these applications, and you have all other orchestration or different type of platforms or tools that are out there. So for example, like the Hyperledger Cello that enables the orchestration of these Docker virtual machines for you to have the private network to use this. So where does actually this leads to? You might say nowhere, but it's not where it's going. Blockchain actually opened a new vision about how we envision applications, or how we envision the applications to communicate with each other. So far, it has always been client-server communication. All the applications that we have done, at least the ones that are using data, all the data or all the logic might be stored in a server, and we have some client applications that communicate through the server. This is going back to the applications that we already have prior to internet, and now the applications that we have that are out there on the internet. So it's all client server, so it's all centralized. What blockchain actually opened the door to is this decentralized world and this decentralized applications. This is what it's called a Web 3. So it's a next generation of what we know now as web. The idea would be, as the blockchain has the concept that we have these independent nodes that are communicated on a peer-to-peer basis. We have these applications that are distributed all over the world, and actually they communicate with themselves without having this central authority. And this is the decentralization network. This is actually the benefit of the blockchain technology. This is the door that blockchain opened. In order for us to understand how a decentralized application actually looks like, I would like to make a comparison with the traditional website that we already know how to implement. In comparison with the traditional website, we also have, for example, for implementing a decentralized website, we also have something called a front end. We have the technologies that are pretty close to what we use right now, so we can use tools like JavaScript, we can use Java, or we can use HTML, CSS in order to build this website. This is the same. We have the difference starting from this layer here. So the difference with the traditional website is that we have the API layer that's hosted somewhere, either on a server, on a cloud, or serverless, that's centralized and feeds us with the data from the database. The difference with the decentralized application is that the front end actually communicates with a smart contract. So it initiates transactions on the network, on all of the nodes, and this triggers the smart contract that actually does some computation. And this communicates with the blockchain, and we get the data back. So this is the difference, and this is where it all comes to the discussion whether the blockchain is a database or not. There are technologies that actually want to tackle this in order to have the blockchain considered as a database. So what do we need to build an Ethereum decentralized application? So there's a lot of tools out there, but basically they can be divided in 3 categories. We have the clients. So in order to communicate with the blockchain or with the other peers on the network, you need a client. Ethereum has implemented clients in different languages, so in Go, in C++, in Python, and when you download a wallet, or when you can download also a client, when you download this, you have the client inside of your software, and basically this client has the algorithms implemented in order to communicate and store all the data. So you have the capability locally at your machine. This is why you have the need for a large hard drive, for example. Also, there are these light clients that can be used either for during development or during testing. So these actually are mocking the implementation of the real clients, and we can basically use them during development. So this is where TestRPC comes into place. We have also these libraries. These libraries are our connection with the existing types of applications that we do with the clients. What they actually do is they proxy our calls from the application at the language that we know. So basically, this might be the .NET framework, this is the JavaScript, and this is the Java library. And they proxy our calls to the clients, and those clients provide these APIs basically to communicate with the database. This is how it all connects. So in order to use all of this, we have additional development tools. So pretty straightforward and pretty simple. You all know this. You have a lot of tools, and everybody uses all of them. So we have this truffle library that basically contains and is really useful. It's based on JavaScript, and it provides a good wrapper around the development and the capabilities that actually are provided by the clients. And you have the Remix. Remix is an online development environment that can help in development of the Solidity contracts. And I would like to mention the MetaMask. It's a really useful Chrome plugin that can be used as a lightweight client. So we will see it in the presentation afterwards, what it does. How it all connects together, I already mentioned, is that we have an application that uses the appropriate library to communicate, and then through remote procedure calls, we communicate with the client, and the client then communicates with the database. Simple. Or not simple. Okay, another picture about how Ethereum actually envisions the applications, but I just wanted to use this picture in order for everybody to know how we divide, basically in the terms that we already know, the applications that we now do that are distributed also have a back end and also have a front end. So the front end will be the part that we implement in one of these technologies like HTML, CSS, and JavaScript. And the backend is actually the communication with the client, and afterwards communication with the blockchain. And the blockchain is actually our database. But we will see this in a few moments. Okay, so my really simple application for this event is using this. I started with the Meteor framework, wanted to use the JavaScript, and this is the front-end part. I used the MetaMask and of course, HTML, CSS to have some sort of a page. You'll see it's not that pretty. And the backend basically is the Meteor application. It's hosted by Meteor, and it uses JavaScript. On the client side, I started using the Go client and also the test RPC, but I will show you how this all connects through MetaMask, so it kind of skips all of these technologies and goes directly to the Ethereum. And on the Ethereum part, I will show you the smart contract that I did and basically posted it on the network, and then how I communicate with this other layers of the application. So it's time to start coding something. I hardly waited this part. Okay, so first of all, I want to show you the structure of my application. So I mentioned I used Meteor. Meteor is a really good framework for rapid application development because it contains a lot of packages, and they're out there. You just include them and you get a lot of functionality into them. How this is going in production, it's a different story, but the idea here is to have something to be shown. So in order for me to use the Web3.js library, the JavaScript library, I just needed to add the Web3.js package into Meteor, and then I have the capability to use this in the JavaScript code. So from the implementation point of view, I have nothing more than just one HTML file and two JavaScript that contain all the code. One is for initialization of the Web3 object. This is actually our connection to the blockchain from JavaScript, and the other one contains the logic where we communicate with the blockchain. So this is it. The HTML part, nothing specific, but we will see into more details later on. What was my idea? I wanted to build a small application that can maybe be used for containing or storing our public health-related data on the blockchain. Why go with this? I was triggered by 2 or 3 weeks ago by an announcement on the media that Estonia wanted to start its own currency. So we all know that they all are digital, and they do all digital into every sphere of the operation of the country. So I wanted to see what will actually look like to have a small Solidity contract about storing our data related to our health checks on the blockchain. Why have it there? Because this is some data that can be public and that can be used by all the other, I would say, organizations, and to show you how it is to store and to read data from the blockchain. So let's see how this application looks like. As I said, nothing special, but the idea was to show you how it is to communicate with this. So I have a tab, 1, 2, 3 tabs, where I show the information about the account, the balance, and this tab will be to actually show our records that we have on the blockchain. Let's first start with the contract. So this is how the Remix environment looks like. It has a text editor when we can write our contracts, and this is my contract. My contract is called Public Health Records contract, and it contains nothing more than a constructor and two functions and some data that I store related to our logs. Nothing special. This is the read operation, and this is the append operation. What is out there additionally to this is the Remix has its own compiler, so it compiles as you write, and it gives you all the errors if you somewhere make a mistake. And on the other hand, when you are finished, you can use this tab actually to create or to send this contract to the network. Once this is done, you can then communicate and initiate transactions that call this contract. So in order for me to do this, I will show you how this MetaMask plugin operates. MetaMask is an extension. It's out there with all the extensions in Chrome, and you can install it. And what it enables you is basically gives you an information about the accounts that you have and enables you to connect to different types of networks. So this is some of the transactions that I initiated earlier. It shows a little bit of history, how much Ether have I spent, and how much Ether I have left. So it's 18 Ether, around $25,000. So, but of course, this is on testnet. So, it also enables us to communicate with different type of networks. So the main Ethereum network, if I connect to this, okay, I will not connect to this because I'm not connected to the internet. But now let's try it. So if I connect to this network, let's try this one. Where did the iPhone go? iPhone. Somebody's hacking the network. Okay, the idea was I wanted to show you that when I change this, it will actually check my balance on the real network, and afterwards it will show me the history here. But since we don't have the internet, we cannot see this. Okay. What is interesting here to know is when we initially create these, they are published, and every contract has its own address. So this is what we need in order for us to okay, we have internet. This is what we need in order for us to communicate with the contract. The almighty iPhone, yeah. So this is what we need in order to communicate with the contract. Every contract has its address, and every contract has some sort of signature. And this is where we go into code. So I have some variables here, address of the contract, and this is something called application binary interface array. It's basically some dull code that we see here and describes our functions and our properties in the contract in order for these clients to communicate to this contract. But the interesting part is actually here. So this is all that I need to do in order to communicate, in order to communicate with the blockchain. So I have the Web3 object. It has property ETH, and then I have data about my accounts. And this is how I get my account. So basically the account that I use in the MetaMask to communicate with the client. On the other hand, I have additional methods that I can use, like the get balance, to give me my balance. And also, I have the ability to call a contract. This is how I generate a contract. So I call a contract using the ABI interface. This gives us the methods that we have, and on the other hand, I need to specify the contract address, because these contracts can be published on the network multiple times, and I need to have the address about which contracts. After this, when I get this contract, I have the methods and the properties that I can call like a regular function. I have only 2 minutes left, so, and this is all the code that I have for now. This afterwards binds to the HTML data, but this is the boring part, and now let's go and execute something. Use your time wisely. So if I connect here, I was here, this is where I have, the 25,000. So clicking this button, refresh data, actually initiates all of these transactions, and I would get the address of my account here. I would get in way, this is the little part of the Ethereum. One Ethereum holds, I don't know how much, thousands of way. And on this part, I would also get my records that I already previously recorded in the blockchain. So in order to save some time, you need to trust me on this one. Okay, so it works. So it's nothing too showy about this, but the idea is that I initiated a call on the blockchain. It gave me the data that I already populated on the blockchain. It's out there forever, so you cannot delete this. And it gave a picture about how I use this Web3 JavaScript interface. This here, called injected Web3, is what MetaMask actually does, is to inject its own implementation in order for me to communicate through it with the blockchain network. Okay. So, what this actually means? What is there for the future? So, Ethereum, when it initially started, it was supposed to go through these 4 phases. The current phase is a homestead phase, so we are now in the second phase with the implementation of Ethereum. So, even when they initially started the Ethereum, they knew that there will be some changes because the technology was so new. And what we might expect in the next stage, called Metropolis and Serenity. So the first expectations is that they will do some abstractions in order for us to easily communicate and to be able to decouple all of this stuff that now came with the Ethereum network. So maybe they will do some abstractions in order for us to store more data and not retrieve all of the data. It's one of the initiatives. So this is called Ethereum improvement procedures, I think it was. The next thing would be for them, they also want to implement proof of stake here, but something on not a larger scale. So this will be as an optional thing for the Ethereum. And at some point in the next phase, in the Serenity phase, they want to replace all the proof of work, basically consensus from the nodes, and for them to be able to use the new one, the proof of stake. They also want to address the scalability of the database, so they want to shard the database. And the ultimate idea that they would like to do is for Ethereum to be invisible. So all of this stuff that we already know that are blocking us to use the Ethereum or the blockchain, they want to disappear, and this technology to be used seamlessly. So basically, they want to do a big bang with Ethereum and use it everywhere. But there are a couple of other initiatives as well. As I already said, now all the blockchains are working in isolation. So this is based on different rules or different properties, different types of executing code. And this is basically where the initiative goes in the future. The idea would be for all of these technologies to cooperate with one another. and it's also found on the internet as called as Internet, not of things, but Internet of Chains. So in the future, we might expect some initiatives and some technologies there to be able to cooperate between these chains. So this means exchange of value, exchange of authorities, or some different thing. There is already something started. These are all initiatives in the early phases of development. So Cosmos is one of the implementation that's supposed to address exchange of values between these chains. And Polkadot is one other initiative that works on top of this and basically wants to exchange information, not just the value transfer, but also information about the data stored, information about the smart contracts, in order for all of these blockchains to communicate with one another. So the takeaway from this representation: blockchain opened the door for the next generation of web and decentralized applications. Hyperledger, on the other side, is one of the tools that is out there for enterprise implementations and for private implementations, but it is a robust toolkit. Ethereum has a pretty straightforward and a lot of community, good community, in order for you to start developing this decentralized application. The next thing with Ethereum is to moving more into abstraction and solving some of the issues that we have with the blockchain, so we can expect this to be even more interesting in the future. The next thing into blockchain technology might be the cooperation between the technologies, and of course, blockchain came and blockchain is here to stay. So we can expect more from blockchain in the future. So this is all from my part. Thank you.
Since we don't have time to talk about this at work, we can do it here.
We might have in the near future.
Yeah. What's the incentive in the distributed apps?
The incentive in the distributed apps. So basically, to initiate a transaction, you need to spend money. So the distributed apps provide incentives if we're talking about the coins. Every blockchain functions on the similar or the same principle. So in order to do some work, you need to pay for it. So the incentive is there for the miners, actually, to validate and to secure this trust on the blockchain. So there isn't any incentive for using the smart contracts. So you need to pay for this service on the blockchain. This is how the blockchain actually works. So if you want to have an application that's decentralized, you need to be prepared to pay money every time you store something on the blockchain.
Can you know upfront how much you should pay for a transaction?
Really interesting question. And I don't even know how much dollars do I have on my wallet. So, but there is an option in this MetaMask actually that gives you a calculation, a rough calculation that actually proposes what amount of way you need to put when you initiate a transaction.
So actually, if you don't put enough way, it will be declined as a whole, and
Yes.
if you put enough, it will be distributed throughout the whole system, no matter how much you gave.
Actually, the blockchain is a pretty fair network. So, if you, in a sense, if you offer more money, more ether, for example, if we speak about Ethereum, if you put more ether that's available for the miners to give, to take, basically, they will take as much as they spent on the network. So the remaining will be returned to you. This is the fairness part. And the other part that enables also the security and the trust is if you initiate a transaction and you don't have enough money for this transaction, basically, the spent time for the miners to calculate all of these hashes and to execute your transaction, and basically to execute your code. So if there's not enough money in the initial transaction, they will take away all the money and they will return back the transaction as not valid. So you need to put either the correct amount of money or either more money than is necessary, but if it's more, the amount will be returned, refunded for you. And this is, on the other hand, failed transactions are charged, and this is how, related to the previous question that Alexander had, how blockchain provides this security from someone willing to flood our network with false transactions.
Goce, you say blockchain is here to stay. How would you comment the statement made by the CEO of JP Morgan? He said a few days ago that Bitcoin is just a fraud, and it's a matter of time until it gets exposed.
Well, Bitcoin is the initial coin that utilized the blockchain technology. So when we discuss about blockchain technology, we discussed about a ripple of events that's behind the Bitcoin. So whether Bitcoin or other coins will stay, I also have doubts, because it's not regulated, so it's kind of a bubble that at some point might explode. But the blockchain technology that drives all of this is the thing that will stay. So this is actually that brings us to the next generation and the mutation of the web. So that's why it will stay, because by my opinion, we are now more closer than ever to having these decentralized applications than anywhere before. Okay, thank you very much.